Up to now, we've talked about two figures being congruent, which means the same size and shape. And now we're going to leave that behind a little bit and just talk about what happens if two figures are the same shape but not necessarily the same size. And that's what we called similar. So what does it mean for something to be similar? Same shape but not necessarily same size. And so we need to be able to identify whether they're exactly the same shape and be able to name them if they are similar. So how do we show that two things were similar? We said that means that their angles have to be congruent. So angles are congruent still, but the sides are proportional. What that means is whatever number that I multiply 45 by to get 27, I would also have to multiply 25 by to get 15, and the same number, 35 times something, is 21. And that number is called your scale factor. So the number that we multiplied our sides by was to determine was the scale factor. And so we found the scale factor by comparing the two sides. So unless they tell me big to little or little to big or left to right, you can choose. I'm going to say my scale factor would be something like 45 over 27. And then that's going to reduce down. I can divide them both by 9, so this is going to be, my scale factor is 5/3. So that would actually be 27 times 5/3 would give me 45. If I wanted the other way around, I would flip it over. So 3/5, 45 times 3/5 would give me 27. And it needs to be that same number every single time, no matter which pair of sides I compare. As long as I'm going with longest side here, middle side here, shortest side here, shortest side here, you gotta compare. And then if I want to say that two figures are similar, so if I have triangle JKL, I have to match up the congruent angles and also the proportional sides. So I'm going to say JKL is similar to, well, J is between the longest side and the shortest side. So looking over here, between the longest side and the shortest side would be G. And then K is between the shortest side and the middle side. So between the shortest side and the middle side, is F for my other triangle. And L would be the one that's left, so GFE. And again, this triangle could be rotated, can be flipped. That's fine as long as I can find proportional sides. And when we were told two figures were similar, we could use that proportion to set up an equation to solve for x. So there's no examples of that here. You have to go back and look at your lesson from 6.1 in order to see an example of that. So then from there, we zeroed in on triangles and we said, how can we prove that triangles are similar? And we started out with the angle. So if I have two angles, then the third angle is automatically congruent and I'm good. Or I could have side, angle, side, where the sides are this time proportional, not congruent. And side, 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 where again, the sides are proportional. And we use these similarity postulates to solve for missing information and to prove if two triangles are similar. So examples of this would be, if these two sides are parallel, then I know that my alternate interior angles, if with either of these being the transversal, are going to be congruent. So if I have angle N here is going to be congruent to angle Q. So angle N is congruent to angle Q. And I could say M and R as well, or I can also say vertical angles are congruent. So these ones on either side, angle MPN is congruent to angle, let's see, that would be RPQ. And so then I know that two triangles are congruent by angle, and so angle PRQ is going to correspond to triangle PMN. So PR with nothing, M with nothing, and N and Q with one arc that I said they were congruent. So that's angle. Then I could also show that the sides of these triangles are proportional. And again, when you do that, you have to say longest side, so 60 to longest side over 80. Does that equal middle side 48 over middle side 64? And is that equal to then 42 over 56? Do I get that same proportionality constant in all cases? And I think we end up with 3 over 4 as a fraction, or 0.75 as a decimal. So if all my sides are proportional, then yes, I do by SSS. And this is going to be, let's see, longest side to shortest side is, T is longest side to middle side, so that would be longest side to middle side on this one is A. U is between the longest side and the shortest side, so over here between the longest side and the shortest side is R, and then our last letter is M. So I have triangle tough is similar to triangle arm. So that was SSS, and then the last one that we had was SAS. So again, I've got these vertical angles here are congruent to each other, and hopefully my sides are going to turn out to be proportional. So I'm going to take the longer side, 24, over the longer side, 12, and is that equal to my shorter side, 18, over my shorter side, 9, and they both work out to be 2. So yes, by SAS, I have indeed similarity. I guess I should write down also the angle. So angle DFE is congruent to angle, let's see, DF would be AFR. And so if I have triangle, then FED, so F from the center is going to be on the same here, F from the center. And then FE, that's along my shorter line, so F to R, FRA. So Fed, FRA. The last section in this unit was the side splitter theorem. And so the side splitter theorem said if I had a triangle and I put another line that was parallel to the base of my triangle, that I split my sides proportionally. And we can use that to solve for missing lengths. And then we also said if those sides don't happen to make up a full triangle, if I've just got parallel lines and I put another parallel line in the middle, again, I'm going to get proportionality. So we did a lot of solving ratios in this one. So if I'm looking at this, I want to find this missing side, which corresponds to my 8 over here. And on this side, all I've got to work with is a 3. So if I can figure out, I first got to figure out what is this side. So I'm going to call this, I don't know, B. To figure out what B is, because 3 is to B as our question mark is to 8. So if I know my whole long side is 12 and I have this little piece here as 8, that means this piece that's not written down, that must be a 4. And so then again write my proportionality constant. So question mark is to 8, as 3 is to 4. Cross multiply those. You can use x if you want to, and divide to solve. So again, 4 times question mark, 8 times 3, 24, divided by 4, question mark equals 6. Sometimes when we did these, they were a little more complicated because I had an x going on here, but it's going to be the same idea. 4 is to 8 as 6x minus 2 is to this missing bit. So I can go 24 minus 8, that's going to get me 16. And then I'm going to write my proportionality equation. So I'm going to put the 6x minus 2 on top. So 6 minus x minus 2 is to 16 as 14, so it has to be on the same side, is to 8. And then instead of cross multiplying, because I've already got it on top, I'm just going to multiply by the 16. And you could have actually done that over here as well. It could have just multiplied the 8 up, and you would get 3 times 8 over 4, which is, again, going to get you 6. So I'm going to multiply this one up by 16 so that the 16s cancel, and then I've got 6x minus 2 is equal to, let's see, on this side, I can go 16 over 8. 16 over 8, or 16 divided by 8 is just going to leave me with a 2 there. So 14 times 2 is 28. And then I've got a straight up linear equation that I can just solve. So move the 2 to the other side. So I've got 6x, 28 plus 2 is 30. And divide out the 6 to get x equals 5. Depending on what they asked you for, if you needed to actually find this, you would plug it back in, 6 times 5 minus 2, and get a number for this length. And again, so that worked with triangles, where I drew in a line that was parallel to my base. It also worked when I didn't have full triangles, but I had 2 lines that were not parallel, and then 2 lines that are parallel, and you draw one in the middle. You can use proportionality to figure out what we're looking for. And we can also use the full length of my side, not just the pieces. So in this case, 8 is going to be to question mark as, well, I don't know, 4 is to, I need to either figure out what this is, or 3 is to, and I would have to figure out what this is. So this one's a little complicated because I have my question mark on this side. It would be like question mark minus 4, which is going to be just annoying. But over here, this one's fairly simple because I can go 8 minus 3 is 5 here, and then compare 4 is to 5. Again, I'm going to put my question mark on top just because it's more convenient. So question mark, which is the whole length, is to 8, as 4 is to 5. And this time maybe I will just multiply. So I'm going to multiply the 8 up to the other side. So times 8 times 8. And this one's going to be either a fraction or a decimal. Doesn't really matter to me which you do. 4 times 8 is going to be 32 over 5. Or if you make that a decimal, I think that comes out to 6.4. So again, when you set up these proportions, you need to pick sides that are corresponding. So 4 and 5 are the longer bits on these ones. The question mark and the 8 is the whole length. And if question mark and 4 go together, then they both need to be on top together or both on the bottom together. So 8 and 5 are together, they need to go on the bottom together. Or you can flip everything over and it will work out just fine. You could also do, if you wanted to, question mark over 4 is as 8 is to 5. You can compare the same side as long as, again, you're consistent with if the whole length is on the top, then the whole length has to be on the top on the other side as well. So there's different ways you can set this up. So it looks like this side measurement actually moved a little bit before I got it to print. So this actually should go the whole way here. I think I can fix that. Sorry, I'm not sure if I was able to fix that on yours, but if it isn't, go ahead and erase it and fix it. All right, there we go, that's better. So that 7 applies to the whole length along the right-hand side, and the x plus 5 is the whole length along the left-hand side. And again, if I don't have the parts that match each other, I've got to do a little bit of subtraction or whatever to figure out what would either go with the 8 or what would go with the 3. And again, because there's an x on this side, I think I'm going to choose this side. Then go 7 minus 3, that gives me a 4 here, and then I can go x plus 5 is to 7, so long side to long side, as 8 is to 4. And again, you can either cross multiply and then divide out later, or because I put the x plus 5 on top, I'm going to just multiply by 7 on both sides. So I wrote 4. Multiply by 7 on both sides, and that will get me what x plus 5 is equal to. So x plus 5 is equal to, type that into your calculator, or you can do in your head, 8 over 4 is 2, times 7 is 14. And then subtract the 5 to get x equals 7. And if they asked me to plug it, or to find the whole length, then I would just put back in 7 plus 5 is 12, and that would give me this whole length there. Sorry, I messed up. It's not 7. 14 minus 5 is 9. I thought there was something weird about that. So I could do 9 plus 5 is 14 is that whole length there. All right, good luck with your practice questions.